Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Understanding upgrade paths is a critical part of operating system support and appears frequently on the A+ Core 2 certification exam. When a user or business wants to move to a newer or more capable version of Windows, there are specific rules about how that upgrade must happen. These rules vary depending on the edition of Windows, whether the version is 32-bit or 64-bit, and whether the installation is tied to a license type like original equipment manufacturer or volume agreement. Questions on the exam often present upgrade scenarios and ask what steps are valid and which ones will fail. An in-place upgrade is a method that retains all personal files, installed applications, and most system settings. This method is ideal for users who want to improve their system without starting from scratch. However, in-place upgrades only work if the existing operating system matches the requirements of the destination version. That means the architecture, edition, and language must be compatible. A clean installation removes all files and installs the new system fresh. This is required when changing from 32-bit to 64-bit, or when licensing restrictions prohibit an in-place upgrade. The certification requires you to know which upgrade paths are allowed and which are not. You can upgrade from Windows Home to Windows Pro by entering a valid license key. You cannot downgrade from Pro back to Home without performing a full reinstall. If a company wants to move from Windows Pro to Windows Enterprise, that usually requires a clean install and a volume license agreement. Moving from a 32-bit system to a 64-bit system always requires wiping the drive and installing the new architecture from installation media. Upgrade paths are also limited by system and edition mismatches. You cannot upgrade to a lower edition, such as going from Windows Pro to Windows Home. Language mismatches, such as moving from English to another language version, will also block the upgrade. A mismatch in processor architecture, such as trying to upgrade from 32-bit to 64-bit without using clean install, will also fail. Microsoft offers tools like the Upgrade Advisor to check eligibility before beginning an installation process. Knowing how to run this tool is useful both on the job and on the exam. Windows activation keys are edition-specific and must match the version of Windows being installed. Retail keys purchased independently can be transferred to a new system, while OEM keys are tied to the original hardware and cannot be reused. Volume license keys are used in enterprise environments and are activated through a centralized license server. Understanding which type of key is in use determines whether a reinstall is allowed and whether activation will succeed. These distinctions often appear in exam scenarios related to license transfer and upgrade eligibility. Microsoft provides several tools to assist with upgrades. The Media Creation tool is available for consumers to create bootable installation drives or perform upgrades from within the existing operating system. For businesses, Microsoft Deployment Toolkit, also known as MDT, and System Center Configuration Manager, also known as SCCM, allow technicians to deploy operating systems across multiple devices using network automation and templates. The Upgrade Assistant checks hardware and software compatibility before an upgrade and warns users of any known blockers. Every upgrade should begin with a full backup. Even when performing an in-place upgrade, something may go wrong that results in data loss or system corruption. The Windows Rollback feature is available for a short time after an in-place upgrade, allowing users to return to the previous version if needed. This option is not available when performing a clean install. Technicians should ensure the user understands this distinction and confirms that data is protected before any system upgrade takes place. Licenses used during upgrades may fall under several categories. Full licenses are used for new installations on a blank system. Upgrade licenses are used to move from a previous version to a newer one and require validation of the existing version. OEM licenses are tied to the original hardware and are non-transferable. Volume licenses are issued to businesses and allow mass activation across multiple systems. Technicians must understand the licensing terms to know when an upgrade is legally and technically allowed. Real-world examples help reinforce the upgrade concepts. A small business may purchase systems with Windows Home but require Windows Pro for features like BitLocker or Remote Desktop. In this case, they would perform an in-place upgrade using valid product keys. An enterprise moving to Windows 11 might use SCCM to deploy the new image across all systems using automated tasks. If a technician encounters a system running a 32-bit version of Windows and wants to install additional memory, they must first perform a clean install of the 64-bit version to fully support the hardware. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Understanding memory support differences across Windows editions is just as important as knowing upgrade paths. Each edition supports a different maximum amount of memory, and the limit also depends on whether the operating system is 32-bit or 64-bit. Memory limitations affect system performance and may create confusion during troubleshooting. On the certification exam, you may be asked which edition supports a specific amount of memory, or why an upgraded system is not recognizing all installed RAM. Windows 10 and Windows 11 each have memory limits based on edition. For 64-bit systems, Windows Home supports up to 128 gigabytes of memory. Windows Pro and Windows Education support up to 2 terabytes. Enterprise Edition also supports up to 2 terabytes of installed RAM. On the other hand, 32-bit editions of any version are limited to about 3.5 gigabytes of usable memory. Even if the system has more installed, it cannot access the extra due to architectural limits. To verify how much memory the operating system recognizes, technicians can use the System Information tool or the Performance tab in Task Manager. These tools show how much memory is installed and how much is actually usable. In some cases, the installed memory may be higher than what the system can use. This can be due to hardware reservations, shared video memory, or system configuration limits. The firmware, such as the basic input-output system or unified extensible firmware interface, may also cap usable memory through specific settings. The motherboard also affects total RAM capacity. Each system board supports a specific number of memory slots and has a maximum memory capacity defined by the chipset. Even if the operating system can support more RAM, the board may not be able to physically or electrically address it. When planning a memory upgrade, technicians must confirm the board's documentation to determine how many slots are available and what the maximum supported speed and size are. Processor compatibility also plays a role and must be factored in. Memory channels should also be considered during installation. Most modern systems support dual-channel or quad-channel memory configurations. Installing RAM in matched pairs or groups allows the system to access memory more efficiently and increase throughput. Technicians should consult the system or motherboard manual to determine optimal slot population. Unbalanced memory configurations may work but do not provide the best performance. Channel configuration becomes especially important when dealing with high-demand systems. Virtual memory is another factor that relates to system performance and available memory. When physical memory runs low, the system uses disk space as temporary memory. This is called the page file and is managed by the operating system. In most cases, Windows handles page file size automatically, but it can be configured manually. Virtual memory should not be confused with physical memory. It does not replace RAM, but helps prevent system crashes when real memory is exhausted. Before installing additional memory, several preparation steps must be followed. First, verify the operating system version, edition, and architecture to ensure that it can support the amount of memory you plan to install. Then check the motherboard specifications for slot layout, speed compatibility, and supported memory types. Always select memory that matches the required voltage and form factor. During physical installation, use electrostatic discharge protection to avoid damaging components with static electricity. If memory is installed but not fully recognized by the operating system, troubleshooting must begin with hardware and configuration. The firmware may detect the correct amount of RAM, but the system still shows less usable memory. This is often caused by running a 32-bit operating system which cannot address large memory ranges. Another cause may be that the system is reserving memory for hardware devices. Technicians should also check the msconfig tool to see if memory limits have been set in the system boot configuration. A common exam scenario may describe a technician upgrading a system from 4 GB to 16 GB of memory. After installation, only 4 GB are reported as usable. Upon investigation, it is found that the system is running a 32-bit version of Windows. Upgrading the operating system to a 64-bit version resolves the issue, allowing the system to recognize and use all installed memory. This type of scenario highlights the importance of matching operating system architecture to hardware capabilities. In summary, system upgrades and memory support are closely linked. Technicians must understand addition limits, licensing constraints, and architectural differences to perform upgrades successfully. They must also know how to verify memory recognition, configure systems for optimal performance, and troubleshoot problems when the system does not report expected values. These topics appear frequently on the exam and reflect real challenges faced in professional support roles. Mastery of upgrade rules and memory planning contributes directly to exam success and on-the-job performance. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.